Hi, this is Grace from Esri. In this video, we will follow the author and share a local scene tutorial in ArcGIS Pro. This tutorial focuses on adding data to a local scene, extruding buildings so they display at their actual heights, comparing elevation layers, and sharing the scene to ArcGIS Online. You can follow the step-by-step instructions for this tutorial in the ArcGIS Pro documentation. Let's get started. I've downloaded our data from ArcGIS Online, started ArcGIS Pro, and opened the local scene template. First, we will reset the panes for mapping to close everything but the contents and catalog panes. Next, we will add our geodatabase that we downloaded from ArcGIS Online. In the catalog pane, right-click on Databases and Add Database. Navigate to where you downloaded the data and select the Victoria University Geodatabase. Set the new geodatabase as the default. Expand the geodatabase and add the buildings layer to your map. The scene automatically zooms into our study area, which is a collection of buildings near Victoria University in Wellington, New Zealand. Your buildings may be a different color. Explore the 3D scene by zooming, panning, and tilting to view the buildings and elevation surface from different angles. You will notice that the ground is not flat because local scenes are supplied with a default elevation layer. If you get lost, right-click the buildings layer in the Contents pane and click Zoom to Layer. We will now take a look at the Layers attribute table to better understand our data. Pay particular attention to the height field, which we will use next to extrude our buildings. We will extrude the buildings so they display at their heights in the attribute table. Make sure the buildings layer is selected and click the Feature Layer tab. In the extrusion group, click Type and select Max Height. Next, tell the buildings what height to display at by setting the field to Height. We will symbolize the buildings to give them a more appropriate color. Open the Symbology pane and search for Building. Expand the ArcGIS 2D symbols and click the dark gray building footprint. Make sure to save the project. Next, we will convert the buildings to Multipatch features to prevent the 3D buildings from being flattened when we share the scene to ArcGIS Online. Open the Geoprocessing pane and search for Layer 3D to Feature class and click the first result. Use the Buildings layer as your input feature layer, rename the Output feature class to Buildings 3D, and run the tool. The new Multipatch layer looks identical to the original Buildings layer and uses the same symbology. Open the Buildings 3D attribute table. It looks similar to the Buildings attribute table, but note that the shape is now Multipatch. Remove the old Buildings layer and switch back to the Catalog pane. See that the Victoria University Geodatabase now has the original Buildings feature class and the Multipatch feature class you just created. Let's add OpenStreetmap 3D trees to our scene. The crowdsourced trees will enrich the scene with more detail. In the Catalog pane, switch to the Portal tab and click Living Atlas. Search for OpenStreetmap 3D trees. Add the OpenStreetmap thematic trees to your current map. Explore the scene to see the distribution of the trees, and then zoom back to the Buildings layer. The scene you created came with an elevation layer, which is a 3D surface on top of which other data is drawn. Without an elevation layer, the ground would look flat. The default layer has different resolutions for different parts of the world. Let's check its resolution for our study area. Start by searching for Elevation Coverage Map in the Living Atlas search bar. Add the elevation coverage map to a new map and expand the values to see how elevation coverage varies throughout the world. In the Map tab, click Locate and search for Wellington, New Zealand. Click anywhere near Wellington to see a pop-up of the elevation coverage map's values. Note that the pixel size has a resolution of 1 meter. Close the pop-up, locate pane, and map view. We also have our own elevation dataset. Let's see how it compares to the default elevation layer. In the Contents pane, right-click Ground and click Add Elevation Source Layer. Navigate to where you downloaded your data and add the local DEM TIFF file. The scene reloads to display the new ground surface. Open the DEM's properties to check its resolution. In the Source tab, expand the Spatial Reference dropdown to see that the linear unit is meters. Next, expand raster information and note that the X and Y cell sizes are both around 1.35. A resolution of 1 meter means that the data stores one elevation value per square meter of ground. A resolution of 1.35 is slightly worse than that. Thus, the supplied DEM is better suited to our study area. Remove the local DEM. We will edit some of the scene's properties. Change the name to Victoria University and allow assignment of unique numeric IDs for sharing web layers. ArcGIS Online uses these layer IDs to keep track of layers if you later overwrite the web scene. Fill in the metadata from the written tutorial. Configure the illumination settings to create 3D shadows based on the local date and time. When you share a local scene to the web, its coordinate system must match the coordinate system of the base map and elevation surface layers. Change the coordinate system from a local projection to WGS 1984 Web Mercator so that the scene can be shared later to ArcGIS Online. The scene will redraw with the new coordinate system and illumination settings. On the Share tab, click Web Scene. You can see the metadata you added earlier. In the Content tab, you can view the content that will be created once you share the scene. The Existing Content tab displays the existing layers that will be included when you share the scene. This includes the elevation layer, the OpenStreetmap thematic trees, and the base map layers. Click Analyze to check for potential warnings and errors. If no errors are returned, click Share to share the scene to ArcGIS Online. This may take a few minutes. When sharing has completed, a blue success message will appear at the bottom of the sharing pane. However, caching is still in progress, so it is recommended to wait for a green message that caching has completed before opening your web scene. Once the success message appears, click the Manage the Web Scene link to open the scene in ArcGIS Online. The item page displays the metadata you added earlier, such as the summary, description, tags, and credits. Open the scene in Scene Viewer. The scene opens in ArcGIS Online to show the 3D buildings and OpenStreetmap trees. You can explore the scene in ArcGIS Online in the same way you did in ArcGIS Pro. Zoom, pan, and tilt the scene to see the buildings and trees from different angles. Click on a few features to see pop-ups of their attributes. Save the web scene and accept all defaults. Go back to your content page to see what was created when you shared the scene. This includes a web scene, a scene layer with its associated feature layer, and a surface definition. Optionally, you can reopen the web scene and add OpenStreetmap 3D buildings as context for the web scene. For more detailed steps, follow the full written tutorial in the ArcGIS Pro documentation linked in the description for this video.